Okay. This is practice midterm number 3. This group of questions is 36 through 40, which is the last in the sequence of questions that are going to employ information that is common to questions 22 through 40. So we'll get to the approach we're going to take to this problem in a moment. But the question is, identify the molecular geometry of the following molecules as A, linear, B, bent, C, tetrahedral, D, trigonal bipyramidal, and E, trigonal planar. And before we start discussing these molecules, I want to refer you to the strategy which we've already reviewed on many of the previous questions, because this is applicable for 22 through 40 questions, number 22 through 40. And this is on our scratch paper. Before we even attempt these problems, in order to use our time most efficiently and effectively in the class on the test, you will have already determined what molecules we're going to be getting information on, and we'll have drawn out the proper Lewis dot structures for all of those molecules on scratch paper, and have been already using it to solve the first, let me see, we're at 36, so the first 14 questions before this, you used the information from this. So draw these out, and I detailed these two in the first questions set, which is from 22 to somewhere. So this is already done. Have this ready, and then you can easily answer the questions. So let's go to the questions. The first molecule in question number 36 is the perchlorate ion. And we've got the perchlorate ion depicted up here on the scratch paper. And the molecular geometry differs from the E-pair geometry in that this is just the geometry of the atoms themselves. The lone pairs on the central atom are not included in this geometry. But in this case, with the perchlorate, there are no lone pairs in the central atom, and I have tetrahedral molecular geometry. So that is option C. Now, number 37 is the carbon disulfide, which we have on our scratch paper. We see that there are no lone pairs on the central atom. The molecule had linear E-pair geometry, and we also have linear molecular geometry. The atoms are themselves arranged in a linear sense about the central atom. So that is option A. Now for number 38, we have sulfur trioxide. Sulfur trioxide is depicted over here. Again, no lone pairs on the central atom, and so the molecular geometry and the E-pair geometry again are going to agree. I've got a trigonal planar arrangement because I've got the 3 atoms arranged all lie in the plane, common plane with the central atom, and they're trigonally they're disposed at 120-degree angles within the plane, and so that is trigonal planar geometry, which is option E. My number 2 pencil on my Scantron sheet. And now we have number 39, which is nitrogen trifluoride. And this on my scratch paper is one of the this is the first time we've encountered this one, I believe, in our considerations. But it's very reminiscent of the ammonia molecule, because particularly when we consider the central atom, the nitrogen I've got 3 single bonds to fluorine and a lone pair on the nitrogen central atom. So it's going to have tetrahedral E-pair geometry, but the atoms themselves, because we don't take the lone pair into account when we're discussing the molecular geometry, this is called a trigonal pyramidal molecular geometry. The remaining atoms, all, these 3 fluorine atoms occupy what would be the base of a trigonal pyramid, of a pyramid with nitrogen at the top of the pyramid, and so the apex side. This would be trigonal bipyramidal. Is it trigonal bipyramidal or trigonal pyramidal? Oh, it's trigonal pyramidal. My bad, I copied that wrong. Option D is trigonal pyramidal. It is an option. It was not a typo on the test. It was a typo on my copying. So this is a trigonal pyramidal structure, which is option D. Now for number 40, I've got the chloride ion. We have over here on my scratch paper. This is very reminiscent of the water molecule. I have 4 E pairs on the central atom, 2 of them bonding and 2 of them lone, just like water. And the arrangement where I have a tetrahedral E-pair geometry, I have a bent molecular geometry because these 3 atoms are not collinear, and I don't have to worry about the lone pairs. So this is a bent molecular geometry, which was option B, which completes this series.